This is grade 7, chapter 10, part 3. So, evaluating expressions. This is a little tricky, so make sure you guys are paying attention here. Let's use cups and counters to model the expression 3x plus 2. So for every x that we use right here, as you can see, every x will equal a cup. So if we have x, and this is x, and this is x, and then we have plus 2, and if you remember back from integers, 2 reds equals a positive 2. So we have x plus red positive 1 plus positive 1. So 3x, there's 3 x's plus 2. So evaluate the expression when x equals 3. So if we know that this is 3 plus 3 plus 3 plus 2, we know that that's going to equal 6, 9, 11. Equals 11. When we plug this back into 3x plus 2, we know that 3 times 3, sorry, that's going to be a plus, equals 11. So x equals 11, or x equals 3, we can plug it into the formula. So evaluate the expression when x equals 4. So every time we're going to go through, we're going to say 4, and we're going to put a 4 here, and we're going to put a 4 there. And we know that 4 plus 4 plus 4 equals 12, plus 2 equals 14. So when we stick this back into the 3x plus 2 equals 4, we know that, or sorry, when x equals 4, we don't know what that equals. Equals, we're not sure. I'll just leave that blank. 3 times 4 plus 2 equals 12 plus 2 equals 14. So we know that that's how the formula works, and then with visuals we can do that as well. So we're going to try this at home. Use cups to model the expression 2y plus 4. So again, pause this, do this at home or classroom or whatever it is. 2 cups, there's your cups, and each one equals y. And then, so 2 plus, and then you'll have, sorry, we'll use the red ones. 1, 2, 3, 4, and we can just put a positive in there so we know that they're positives. So 2 y's plus 4 positives. So evaluate 2y when y equals 1. So evaluate 2y plus 4 when y equals 1. So to sub this in, we have y, 1 plus 4 equals 6. And to put this in again, that's 2y plus 4, and we'll substitute the y. 2 times 1 plus 4, 2 plus 4 equals 6. So there's 2 ways to do it. I'm trying to show you how to use it with the cups as well as with the formula substitution. So if we're going to evaluate 2y when y equals 3, we know that we put 3 in each cups. 3 plus 4 equals, that's 10. And then if we put this into the formula, 2y plus 4, 2 times 3 plus 4, 2 times 3 is 6, plus 4, and that's 10. Apparently it's school time is over. All right. The next part. So if it says loot, but look at the pattern of squares, it can be described using the expression 2n plus 1, where n is the figure number. So 1 equals n right here. So we have 2n plus 1. What does 2n represent? It represents the amount of squares. In the pattern. So make a table of values for n and 2n plus 1. So we know that the first one, n, and then we'll have, oh, we'll put n at the top actually. So we'll have n, and then amount of squares or tiles, we'll put it as t. Oh man, I hope this bell goes on all the time and we just have this continuously through our videos. So 2n plus 1, if we put 1 where the n is, we know that 2 times 1 is 2, plus 1 equals 3. So your tiles are 3. And that's shown up here as well. Figure 1 has 3 tiles. Figure 2, 1, 2, 3, 4, 5 tiles. So you'll have 5 tiles in the second one. And when we plug in 2n, 2 times 2 is 4, plus 1 is 5. If we have 3, we'll have 6, plus 1 is 7. If we have, and you can see it's going up by 2 because every time we multiply by 2. It starts at 1 above n, one above that because of the plus 1. So when we have 4 times 2, is 8, plus 1 is 9. If we have 5, I hope you're doing this at home, that would be 11, etc., etc., etc. So how many squares are in figure 30 of the pattern? We know that 2n plus 1 is the pattern. So 2 times 30, and we just substitute 30 into n because that's what it is, plus 1. As we move forward, that's 2 times 30 is 60 plus 1. So this total equals 61. There's going to be 61 squares in figure 30 of the pattern. So the next part, or the final example, the number of line segments that form the squares can be described using the expression 3s plus 1, where s is the number of squares. So for every square, there's one square. There's the line segments is 1, 2, 3 plus 1. So there's 2 squares, 1, 2, 3, 1, 2, 3 plus 1. So make a table of values for s and 3s plus 1. So we're going to have s, and we're going to have line segments, so we'll put it as L down there. So again, do this at home. 1, 2, 3, 4, 5, and 6. So when we have 1, we know that 3 times s, and we're just substituting 1 right here. 3 times 1 plus 1, so 3 times 1 is 3, plus 1 is 4. And that checks out because up here we have 4 line segments. So 2, 3 times 2 is 6. This is 2 now. 3 times 2 is 6, plus 1 is 7. So again, it's going up by 3, which is what we're multiplying it by. 3, and there's 7 up here. 1, 2, 3, 4, 5, 6, 7. So we know that there's 7 up here. Figure 3 has 9 plus 1 is 10. Figure 4 is 4 times 3, which is 12, plus 1, which is 13. Figure 5 has 5 times 3, which is 15, plus 1, which is 16. And again, it's going up by 3. 6 times 3 is 18, plus 1 is 19. So that's the amount of squares there are. How many line segments are in figure 12 of this pattern? So again, stop this at home and do this on your own. 3 times 12, that's a 13. I'll make this cleaner. What the? 3 times 12 plus 1. 3 times 12 is 36, plus 1 is 37. So 37 line segments will be in figure 12 of this pattern. Your homework is page 368, 369, questions 5, 6, 7, 8, 9, 10, and 11. 5 through 11. Thanks. If you have questions, come see me.